let's take a look here at what we've got. Okay, so we'll start off very similar to how we did yesterday. In fact, today is going to be very similar to yesterday. It's just going to be cubes and cube roots that we're going to talk about. So we'll start by finding out, kind of like where these cube roots come from, right? So we'll start by looking at cubic functions. Okay. So we want to find the inverse of f of x here. Well, we'll start by changing that f of x to y. Okay. And then what should we do with the x and the y? Swap them, right? Swap x and y. Everything else stays in the same position. Okay. And now what should we do?
Square root. Wait. First do
times 2, okay? Yeah, we got a 0.5 here, so we want to get rid of that 0.5. So you can divide both sides by 0.5 if you want to, or I like the idea of multiplying by 2. So multiply both sides by 2 here. Okay? So we get 2x equals, oops, it should be the whole side here anyway, y cubed. Okay, yeah, so we multiply both sides by 2, so the 2 and the 0.5 cancel there. And then now what's our final step? To get the y by itself. What's with the y we need to get rid of? So not square root though, right? So cube root, because it's the third power. Square root is only for squares, right? The cube root we use to eliminate cubes. So we'll do cube root on both sides. Okay, so you got to put that little 3 in there to show it's a cube root. Okay, these little 3's right here. Okay, so then we'll end up with y equals, and then the cube root of 2x. Now, the cube root of 2x, do I need to put a plus or minus in front of this? No. Cube roots don't need a plus or minus in front, okay? Because when you cube something, right, it like, well, let me see here, goodness. If you cube a negative number, your answer is negative. If you cube a positive number, then your answer is positive, right? So in other words, the plus and minus stuff we don't need to worry about. The cube kind of takes care of that. So any odd-powered root, okay, you don't need to worry about the plus or minus. Any even-powered root, you do have to worry about the plus or minus, okay? Also, yesterday, if you remember, we got into this kind of like weird situation where our inverse, the inverse of x, of an x squared or whatever, the inverse was not a function. If I graph this, and by the way, you can graph cubics on your graphing calculator. There's 2 ways to go about doing that. One way is, I think, if you type in a 3 and then you press the math button, actually, never mind. There's a cube root command. My apologies. There's a cube root command right there. Okay, if you press the math button, just use that. And you can type in then the 2x and then close parentheses like that. Okay, if you have the pretty type, okay, which my calculator does too, the pretty type folks, you're really lucky because then you can just go, well, you can type that one in too, so you can, you can still use math and you can use the cube root if you want to. Or you can also, and well, everyone has this command too, you can use the x square root like that, and that allows you to type in whatever root you want there. So if you want to do a 5th root or a 7th root or a 20th root, kind of thing, you could do that. So you can just type the 3 and then type in whatever you want there. Okay, so the pretty type's really nice. All right, anyway, we graph it. Okay, there's our inverse. Okay, is the inverse a function? Does it pass the vertical line test? Yeah, it does. So there's no restrictions. There's no like weird restrictions like we had to do yesterday, right? Where we said, these 2 functions are inverses for this x value greater than 0, kind of thing. We don't have to worry about that here. It just works out real nice. Okay, so I showed you the more difficult example yesterday. This one's not so bad. All right, and just so you guys can see, I'll also plot the original function too, so you can kind of appreciate the. I'll put the x in there too. So there's the original function, right? And there's that line y equals x. And you can totally see, actually let me do zoom square, I think that's going to help out. So there's our inverse. There's the original function, And there's that line y equals x. And you can see that fold, right? You can see how it would perfectly fold over and match up, okay? And that's, again, a property of a function and its inverse, right? Is that a function, if you reflect it over the line y equals x, okay, you get its inverse. So you take the function, reflect it over this line y equals x, and you get the inverse there, okay? So, all right. All right, I'll do one more here, and then I'll have you guys try one too. So let's see here. Okay, so f of x equals x to the third minus 9. Again, we'll change it to y equals x to the third minus 9. Oops, and up here I should have written to officially show that this is the inverse of f, right? I should put f, a little -1 there, cube root of 2x like that. Okay, so that should be the final step there. That's the actual final answer right there.
There's an inverse button on our calculator, right?
There is an inverse button, but it doesn't do what you want it to do, which is like do it for you. It won't do that.
That's what I was wondering.
Yeah, good question. That's great because the calculator does do a lot of things, and of course, I want to share with you guys when you can use it to do that. But unfortunately, no, the calculator won't do it what you want it to do. Yeah. Okay. So, all right, number 2. What's my next step here? I got my y equal x cubed minus 9. I'm trying to find the inverse. So what should I do next? Switch the x and the y. Swap them. Okay. And then? So add 9 to both sides. Okay, so you have plus 9, plus 9. Whoops. Okay. And so now I've got x plus 9 equals y cubed. Final step. Cube root both sides. Very good. Cube root. Cube root. So you get y equals the cube root of the quantity x plus 9. So the whole thing there is underneath the cube root. Okay, which then means f inverse of x is the cube root of x plus 9. Okay, and again, I don't have to worry about any sort of restrictions or no plus or minuses there because it's a cube root. So cube roots are more friendly to us, right? They don't take as much concern or thought there. All right, again, I'll just graph it real quick just to show you that inverse relationship in the graph. Okay, so there's my x cubed minus 9, and I'll do math cube root x plus 9, and I'll graph the line y equals x there just so you can see that reflection line. So there's that. There's the inverse right there, and there's your line y equals x. And again, you can see that reflection property, right? Okay, you can see it. All right. So here's one for y'all to try. Okay, so f of x equals 8x to the third. Go ahead and find the inverse of f. Okay, find f inverse of x, please. Let's go ahead and try that one. Okay. Shouldn't take you too long. there's your answer. Okay. F inverse should be cube root of x over 8, or that actually simplifies to 1/2 the cube root of x. Okay? So how can we see that it simplifies here? Well, when you have the cube root of x over 8, all right, that's the same thing as the cube root of 1/8 times x, right? Dividing by 8 is the same thing as multiplying by 1/8. Okay? And then since the product in here, right, it's 1/8 times x, you can break it up and make it cube root of 1/8 times the cube root of x. The cube root of 1/8, how do we simplify that? Well, just do the cube root of 1. What number times itself, 3 times gives us 1? What's 1, right? Cube root of 1 is 1. The cube root of 8 is 2, right? Because 2 times 2 times 2 gives us 8. So the cube root of 8 is 2. So we just divide 1/2 there. Okay, so you can pull that 1/8 out, make it just 1/2 cube root of x. Okay, this is okay. This is fine. Okay, but we do want to be able to simplify here too, potentially, if we, if needed to. Question? What's the problem? Which? The whole thing or the simplification?
After you did x divided.
Right here?
No.
You're here?
That, yeah.
Okay, so this is where you had trouble? You're not clear about it here?
I'm clear about it, but like,
okay.
You simplify it.
So yeah, if you can get to this point, Mike,
yeah.
that's good. That's good. Okay, that's fine. Okay, but I do want to show you here that you can simplify it further. Okay, I didn't simplify any of these earlier ones because. So let me take a look. Let me show you this one, for example. This one, Mike, we can't break it up because it's got addition. It's x plus 9. You can't break a cube root up over addition. Yeah. Unlike this one, which is like, I changed it to multiplication, right? 1/8 x. That you can break up, okay, if you want to. But if I go back up to here, right, here I have multiplication, but you'll notice I didn't break this one up. Why? Because the cube root of 2 doesn't simplify. It doesn't. You can't simplify any for us. Any further. So we just leave it, right? We just leave it. All right. It just doesn't simplify any further. Okay. So that's why I only did this one here. Okay. So let's take a look then at our transfer. Let's take a look at the graph of the cubic function. All right. We're going to look at the graph of the cubic function. So cube roots, I should say. So graphing cube roots. Okay. So f of x equals the cube root of x. Okay. Now, in a situation like this, we're going to kind of do exactly what we did yesterday, right? We'll just pick some points, and then we'll plug them in and get their matching y value. Pick some x values, plug them in and get their matching y values, and that'll help us figure out what the graph is going to look like. Okay. We don't want to get too crazy here because, well, the numbers can get kind of big pretty quick. Or yeah, anyway. So let's see here. Again, we want to be careful about what x values we pick, at least if we're trying to do this mentally, right? So for example, all right, do I want to pick like 3 as a possible x value for my table here? Yeah, do we know the cube root of 3? No, right? 3 is not a perfect cube, so I wouldn't pick that. But like 0 is a perfect cube. Okay, what is the cube root of 0? 0, yeah, 0 times 0 times 0 gives us 0. Okay, 1 is also a perfect cube. What's the cube root of 1? 1. Okay, -1 is a perfect cube. What's the cube root of -1? -1. Yeah, -1 times -1 times -1 gives you -1. All right, I'm going to pick 2 more perfect cubes. What other perfect cubes? What's our next kind of perfect cube after 1? Careful, 9 is a perfect square. 8, yes, 8. 8 is 2 times 2 times 2. Okay, and what's the next perfect cube after 8? 27, yeah, 3 times 3 times 3, okay? And then after 27 is 64, and then 125. Yeah, they start getting out of control pretty quick there, right? So the perfect cubes, because you're cubing something, right? So, 1 times 1 times 1 is 1, 2 times 2 times 2 is 8, 3 times 3 times 3 is 27, 4 times 4 times 4 is 64, 5 times 5 times 5 is 125, 6 times 6 times 6, you get the idea. It gets very large very quick, okay? So those perfect cubes, get out of control. Okay, but there's our table. Okay? So again, you can see our x values spread out pretty quickly. Our y values stay pretty tame, right? Just between -2 and 2. So I'm probably going to count by 2s on my x-axis, and I'll count by 1s on my y-axis there. Just kind of fit everything in nice and neat.
Okay, so 2, 4, 6, 8. We're going to do the same thing here. 2, 4, 6, 8. Okay, and then 1, 2, 3, 4. 1, 2, 3, 4. Okay, and there's my x, and there's my y. All right, and we'll plot this thing. So we got the point -8, -2 right here. Okay, and then -1, so that's like right here. 0, 0, and then 1, 1 right there, and then 8, 2 right here. Okay. Like that. Okay. Whoops, off the screen a little bit there. So there's our graph. Okay. How will we describe the domain of this graph? Negative infinity to positive infinity. Exactly right. Yep. That's different than yesterday, right? Yesterday, it was not all real numbers for our domain. We had a starting point. Okay. What's the range for this graph? What does it look like our lowest y value is going to be? What does it look like our highest y value is going to be?
-4.
So I mean, it looks like it's going to keep going down here. So it's going to be negative infinity to infinity. It will keep going down. Okay, so it will be negative infinity to infinity, all real numbers. So domain's all real numbers, range is all real numbers here. So no problems, right? We can cube root negative numbers, we can cube root positive numbers. We can get negative answers, we can get positive answers here. That's very different than yesterday, right? Where we don't want to square root negative numbers, we get imaginary numbers, right? When we do that, so that's why we had to limit our domain yesterday for the square roots. Okay, remember that graph from yesterday? Let's see here if I've got it up here. Yeah, remember there's our square root right there. Okay, it has to start at 0, 0 because we're not taking the square root of negative numbers. So we just get this little piece right there. Okay, but for cube root, we get much more complete graph. All right. When it comes to transforming, which we're going to talk about next, of course, all right, once we learn about it, once we have our new parent function, we talk about the transformations of it, all right. The key point we're going to be transforming here is that point 0, 0 again. Okay, so 0, 0, that's like the center point of our cubic here. Okay, that's going to be the key point that we're going to transform first, and then we'll figure out the rest of the graph from those. Okay, so all right, CJ. I guess right now. All right. So let's take a look at transformations then. All right, and again, this is like just like what we did yesterday, right? It's like deja vu, except with just cube roots, okay? So transformations. And again, you'll be seeing this transformation stuff at least 2 more times after today, okay? So it's super helpful if you guys can get this stuff down, okay? Super helpful. It'll benefit you. You're investing in your future. Same kind of numbers here, right? Same kind of deals. A, H, K. Okay. The book will also talk about a number inside the cubic next to the x, like a b value here, you might say, like bx minus h. Okay. We're not going to worry about a number in front of the x. That's like a horizontal structure shrink. We're not going to worry about that. Okay. I'm just going to forget about those basically, because we can basically you can rewrite any horizontal structure shrink into a vertical one, so I'm not going to have us worry about those. Okay. All right. So, what does A do again? Vertical stretch or shrink, right? Or if it's negative, it will reflect over the x-axis, right? So I'll write that all over again over here. So A greater than 1, vertical stretch. Okay. 0 less than A less than 1, so A between 0 and 1, vertical shrink. Okay, I'll zoom in some here. Okay, and then a less than 0, reflect over x. Okay. H, what is H in charge of here? What does the H do? Yep, shifts left or right, okay? If we have x minus a positive number, so if we have x minus a positive number, h greater than 0 there, we shift right h. Okay, and if h is less than 0, if we have x minus a negative number, or in other words, x plus positive, all right, x minus a negative number, we shift left h. Okay, and then finally, what does k do? Yeah, it shifts up or down. If k is greater than 0, up. Okay, and if k is less than 0, shift down. Oops, off the screen. Okay, shift up k, shift down k. So, there it is all over again, right? And we'll take a look at an example here. Okay. So I'm just going to throw a cube root at us that's got everything, one with everything. One with everything. Okay. What kind of transformations do we see in this example that we're going to do here? What kind of transformations do we see? Up 5, right 3, vertical stretch by 2. Exactly right. Okay. So those 3 things we're going to do. Now, of course, all right. When it comes to these transformations, right, you only need to really transform that the very first point, or the kind of like the important point, right, of our graph. For these cubic functions, right, I told you that point 0, 0, okay, that's the important point that we want to transform here first. That's like the center of our graph, right, that 0, 0 there. So, if we're going to take that point, well, actually, I'll go ahead. Let me write those transformations out. So, we're going to go right 3, up 5, and then stretch vertically by 2. Okay. So yeah. 0, 0 is our normal kind of center point here. What will that new center point be then? If we shift it right 3 and up 5, what's going to be that new center point? 3, 5, yeah. Okay. So in my table here, I'm going to put that 3, 5 in the center, okay, of the table. Again, right 3, up 5, right? 3, 5 in the center of the table. Okay. And if you remember back to what we had earlier, let's see if I can get this to fit on the top and the bottom there. Fit both. Okay, kind of. We had, there was our center point in the center there, and we had 1 and -1, okay, to the left and to the right. But of course, 1 and -1, those are going to all be shifted. These are x values, right? And they're being shifted right 3. So instead of 1, I have to go right 3 from 1. And this is like my 0. My 1's going to be right here. So right 3 from 1 is going to be at 4 now. Okay? And then -1, right? If I go right 3 from -1, that's going to be now at 2. Okay? And then I also have -8. And I have my 8. But again, those are going to be shifted. We're going to shift them right 3. So instead of -8, we're going to go right 3 from that, so -5. And at +8, we're going to shift right 3. That'll be at 11. Okay? So these are important numbers. Okay? If you're not sure, right, if you're like, I don't know if I'm going to be able to come up with those numbers or whatever kind of thing, you can still go to your calculator and type this in. Cube root x minus 3 and then plus 5. Oops, I don't know why I put it all the way down there. 2 math cube root x minus 3 plus 5. Oops, no parentheses necessary, Mr. Wood. Okay. And you go to your table, and it's going to be very, oops. You go to your table, it'll be very clear what numbers you're supposed to use here, right? Because, like, you get, not so nice numbers, right? You get so, like, probably pretty yucky decimals here, but then some of them are pretty nice, right? So there's our -5, 1. Okay, at 2, the next nice point is 3. Okay, and then at 4, we get 7, and then at 11, we get 9. Okay? So we get some nice points. And again, you're more than welcome to use these other, like, decimally points if you want to. They're just a little bit harder to graph, right? That's all. They're just a little bit harder to graph. But it's your choice. Okay? But there's my nice table of values there. Okay, it gives me some nice table of values. Hello. I thought they were saying hi to me. Got my hopes up. All right. So let's graph this thing. So I can see here for my x values, I have to go from -5 to 11. That's pretty wide, so I'm going to go count by 2s probably. And then for my y values here, I can probably get away by counting by 1s, but I'm going to count by 2s. And I also don't really need a negative y value, right? So I might go ahead and graph it something like this. I'll put my y-axis in the center maybe. But then I'll put my x-axis like down low. Hello.
Hi.
How's it going?
It's an evaluation sheet for
Gotcha. Very good. Thanks, Ian. Yes. Yes. Okay. Right. So we'll count by 2s. So 2, 4, 6, 8, 10, 12. And I'll count by 2s here too. So 2, 4, 6, 8, 10. And that's all I have to go up to for that. -2, 4, 6, 8, 10. Okay. So now we'll plot our points. -5, 1. 2, 3. Okay. 3, 5. Here's our most important point right there. That's our center point right there. Okay. This is the important one right here because that's our center point. Okay. You can think of it like the vertex essentially. Yes. I mean, yeah. You can think of it. It's like our vertex. It's the center point of the thing. Okay. And then 4, 7. Okay. And then 11 and then 9. Okay. And so you can kind of see we're going to come in here. Okay, something like that. Oops, I'm off the screen. There we go. Okay. All right, so questions on any of that? Do we need to see another example of graphing, or are we feeling pretty good? It's very similar to what we did yesterday. So, yeah, Julie?
I don't know, all of this, yesterday there was a minus, right?
Yeah.
And it went to the left. Like, so you know how usually you get a minus, you go to the right.
And with the x, yes. Mm-hmm.
So I just don't understand.
Yesterday we went that. Let me see if I can find that here. Do you remember which one it was? So I think the big deal here is that when I write this out with the transformations, I write it as an x minus an h. And so when I say h is positive here, we shift it right because it's x minus that positive number. Okay? And then when it's x minus, and when h is less than 0, which it means it's x minus a negative number kind of thing, then we do shift it to the left that many units, okay? And I think that's the key, the weird thing here is that I have the minus there, and that can be confusing, I think, with the transformations. But yeah, if you see, so long story short, the minus 3 in with the x there, that means you're shifting right 3. And if you see a plus 3, that means it's a left 3, okay? That, yeah, I mean, so it's just, I think it's just the way that we write it, because it's, yeah, it's hard to write it in a clear way, because either way it's confusing, I think, either way. Anyway, okay, but that's the main idea. I have one more I want to show you then. If you're feeling good about graphs, all right, I have one more I want to show you before I get you started on the assignment here. And that is, I want you to take a look here at, okay, this graph right here, okay? And I want us to be able to come up with an equation for this graph. Okay? Let me zoom out a little bit here. Whoops. Okay. So, what kind of transformations do we see occurring in this graph from our typical parent function of just like the cubic here? What kind of transformations do we see? Is it shifted at all? Okay, it shifted down how much? Yeah, so be careful here. I think each one of these counts by 2's. See what I'm saying here? Like each one of these blocks here is 2, I think. So it's down 2, 4, and then, yeah, the middle point there is 5. Okay, I'm pretty sure that's the vertex there. It's supposed to be 5. Okay, so it's down 5. Okay, so we went down 5. How else is it shifted? Left how much? Left 2. And it looks like it's also reflected, right? So we're going to say A is different, but we're not sure what A is. We can hold off on that for right now. Okay? So what we'll do is we'll just put together the pieces that we have. So we'll say g of x is, okay, we'll leave some space for A here. I'm going to put an A in, actually, times the cube root of x, and then if we're shifted left 2, I need to have x what? Plus 2. And if I have a down 5, what should I put? Where should I put that? Minus 5 at the end, right? Yes. Okay? So, that's great. So to get the A value then, we're going to plug in one of our points. We don't want to use that center point, the center point there at -2, -5. Okay, we're going to use this other point right here. Now what's this coordinate for this point right here? So yeah, -3 is the y value, and what's the x value? Yeah, -1, -3. So we'll put a -3 in for the y. We'll get the A there. Cube root. We'll put a -1 in for the x. Plus 2, minus 5. And then we'll just solve for A. Okay? So -1 plus 2 is 1. The cube root of 1 is 1, so we just have A minus 5 there. Okay? And so we'll add 5 to both sides. Okay? And we get 2 is equal to A. So my A value there is, wait a minute. Feel like that's, oh yeah, that is right. Never mind. It is a positive 2A value. So I was wrong. It's not a flip. There is no flip there. Okay? It's just 2. And so then this becomes 2 cube root x plus 2 minus 5. Just like that. Okay? And there's our answer. All right? So just like the warm-up, right? Just like we did in the warm-up, except the warm-up was square roots, right? Not cube roots. But just like in the warm-up, identify the shift left and right, identify the shift up and down, put those in your function, and then use a point to solve for that A value. Okay? Again, you can sometimes count here. I mean, so, you know, if you really wanted to, you could see, okay, well, from my center point, I'm going up 1, 2, and over 1, right? So I went up 2, right 1. Well, there's the 2, right? Because you went up 2, right 1 to that next point. All right? You can use that, too, if you really want to. You can count it. But also just use a point to supply. Okay? Questions on any of that? another assignment here. Okay, so on page 371, which is module 10.3, section 10.3 in your book, page 371. I said that already. I forgot it. Okay, I would like you to do numbers. Three through 8. Ten through 13. (16 and 20). Okay, and you can skip number 6. Skip number 6. Okay. Okay, so just a heads up. 10 and 11, you are supposed to graph. 10 and 11, you are supposed to graph. 12 and 13, you're coming up with the function that gives you that graph, okay? And then for these 3 through 8, you're just describing the transformations there. All right? I think everything else should be pretty straightforward. Yeah. There you go. Might want to sharpen it, but okay. All right, so let's crack open a book there, or you can pull up the stuff on Google Classroom, of course, in our online textbook. Your choice.